just to start the slideshow. Let's get into it. Writing clean code with multiplayer, now in Unity in brackets here, but I imagine the idea generally moves around. Now first of all, let's start a little bit with who am I. Now, if you've seen my videos before, you know that I'm Bobsi. I'm a game developer who focuses on multiplayer game development, and I have turned full-time on networking and multiplayer around 2022. But I've been playing around with game development ever since 2010, and I think when I started networking in around 2019 or so. I'm the co-owner of the PurrNet networking solution, which is also the one that I'm going to be working with examples today. Now, first of all, what will we be learning and going over today? This is a little bit more of sort of a class structure or course structure. We'll be going over what is clean code, writing clean code, and networking clean code. Because I think it's very important that we set some strong sort of fundamentals before we get into actually networking it. Because networking it is actually quite a small part of it when you understand how to write clean code yourself. Now, of course, you need to be aware of the limitations of the solution you're working with, but we'll get into that in a little bit. Now, first of all, what is clean code? And let me just make it very, very, very clear to you, and I can't stress this enough. That's a lot of ways of going about making clean code. This isn't just some like single thing I can take and put into a box and say this is clean and this is not clean. No, that's not how it works. It really depends on the approach that you as the developer and the system that you're working with will need to take. So it'll depend a lot, and it's very individual, and also it's a very subjective matter. So I know that the fact that I'm making this kind of video can be very provoking, but really just take it as this is one way of going about it. This is one way that I like working with. I'm sure there are ways that other people feel are a lot better, and there probably are a lot of ways that are a lot better. But in my case, and for most situations that I've met in game development, taking this approach and just having this approach in mind will really get me around pretty much any issues that I'm having. So first of all, let's define what is clean code, because clean in the word meaning can also be extremely different. But to me, it means that it has scalability, it has maintainability, and it has high level of modularity. These are really the three sort of key elements of making something clean. But I would also like to put an argument in for a fourth point, which is it shouldn't hold more than necessary. Because I think systems can also very easily be convoluted. I've worked with a lot of developers who sort of over-engineer their systems, which really just makes our workflow a lot slower, and I would argue that's not clean, because now you're hindering our workflow instead of supporting it. And what I mean with scalability, maintainability, and modularity is that we should keep the fact that a game is a very dynamic process in mind. Game development would be extremely easy, unnecessarily easy actually, if you knew upfront exactly what you were making. The issue is we don't. We don't know exactly what we're making because there's a lot of trial and error, there's a lot of testing, there's a lot of prototyping, there's a lot of making systems, tweaking systems, removing systems. There's a lot of dynamic nature to making games. So let's take the example of the images that I've just drawn here, right? The top here is, I would say, an example of not clean code, and this is probably how most developers do it, and this is typically how you learn to work. This will have a lot of dependencies and expectancies, and one of the things that I think make things clean is the fact that you don't sort of hard depend, you don't hard attach stuff to each other. Essentially, the less dependencies you can make, the better. So looking at this top example, as you can see, we have like a player and we have a trap as well. This is, let's say, a trap that the player can put down. And there's a lot of things that we want this, both of these to be able to essentially break or damage or interact with in some kind. Let's say that we have a blockade and we have a crate, we have an enemy and we have a boss. And you might say, well, both the enemy and the boss will just need the, just a health component and that's it. And you might be right. But the thing is, you might want them to act very different, right? A classic case would be that a boss has health in stages or regains health differently than the enemy does. Or, there's a lot of unique abilities that the boss can have that maybe the enemy doesn't, or vice versa for that sake. Or maybe you want the boss to not be able to take fire damage, or want him not to be able to burn, but the normal enemy should, or only some types of enemies should as well. And same goes for the crate and the blockade. You could say, well, both of them should just be broken in one hit, and that might be right, but you might want it to act differently. Maybe a blockade should break in 3 hits and drop off a wood plank every time you hit it, or it should drop some item, a crate should drop an item, but a blockade shouldn't, or whatever. There's heaps of different types of functionality and different ways to tap into them. And the thing is, this sort of system, like the mess that you're seeing here, essentially also goes into the third dimension. This is just a 2D image, so obviously I can't capture that. But imagine that, as I mentioned before, every single enemy, every crate, anything that you can damage can also have various status effects or can have different things impacting them, like maybe some are impacted by weather, maybe some are not. maybe some kind of status effects, some cannot, and so on. And we're really starting to move into not just the second dimension, but sort of starting to add, if you essentially copied them all into the third dimension multiple times as well, and you can very easily sort of start to visualize the kind of net and the mess that we're starting to get, programmatically. Now let's take this bottom example, and of course we're going to get into a little bit what this means anymore, but essentially each of these lines is meant to be one interaction, right? Like the player is set up to do something to the enemy, the player is set up to do something to the boss, and something to the crate, and same as the trap. And again, you can also easily see that as we add another thing, let's say that we wanted an NPC that can help us as well, that'll just add to this net, right? All of a sudden we'll have more for every interaction. Now, these boxes here, and we'll get into what they mean in a bit, but essentially you can see by just boxing the player and the trap and things on this side, essentially the things that will be dealing damage in this case, we're sort of encapsulating them in one box, and then all the things that can somehow, take damage or get interacted with by these, we put them into another box. And all of a sudden you notice there's only one interaction between the boxes. And of course, different status effects can essentially be boxed in the third dimension as well in a similar fashion, so that way we only really have sort of the minimum number of interactions. And this, in my opinion, is clean code, because if we look over here, first of all, scalability means that as we add more components over here, or more over here for that sake, we don't have to add more bindings, right? Which means it's scalable. We can start building more and more stuff. We can make more and more things that take damage. We can start making this NPC I talked about, and we don't have to worry about this connection, because it's already handled by the box, not by the components in the box. Now there's also maintainability. It really goes for the same thing, right? If there's something key that you need to change, let's say with a system like this, all of a sudden we want to actually completely change how things take damage. Well, we essentially have to go through every single interaction and modify it. Where here we only have one line of interaction, so this is the only thing we'd have to modify if we care about how something is taking damage or what happens in between there. And in terms of modularity, same thing as I just mentioned with the scalability, really. We can sort of plug and play, and the thing is, it goes the other way too. It's not just scaling it up. We can also remove things without causing a bad effect, right? In this case, we can just take out the boss block. We can take out the crate if we don't want those anymore. We still only have the one connection. We still have the box keeping everything in. Again, nothing else around has to change. And it's really very non-intrusive to make changes to a good modular system or clean system, in my opinion. So this is what we're going to be working with today. Now, opening up Unity, I've just set up this super basic example in Unity. Now, there is a network manager in here, but we're not doing anything networked at all yet. I essentially want to take you through this step by step by what we're going to end up doing. So first of all, I've made some enemies, and when I press play, you can see they get their health. And when I click on them, we deal 10 damage to them, right? And then when I go all the way down, we kill them. Boop. This is probably a system that you are very familiar with. I imagine most of you have probably made games before where something takes damage. And that's essentially what this is. My player just has like a player clicker on it, and that's all that's happening. You can of course apply this to your code. I don't want to provide you any example code here. Like, I'm going to show coding, but I don't want to give you code to use a copy, because this is just an example setup. But you can see here, as we kill them off, they'll plop out and they're dead, right? So that's essentially the core idea of the system. Now, the setup that I have here, just gonna look in the code. You can see I have the player clicker. I get my mouse down. I throw some kind of raycast. Actually, let me just invert this so for readability. There we go, same functionality. But yeah, essentially I click, I throw my raycast from my camera to my mouse, and I check what I hit, and if what I hit has an enemy health, we'll deal 10 damage. Right, and in the enemy health, pretty simple. I have the damage and the damage that should be dealt. It'll deal the damage, check the health, it'll create the text pop-up, and it'll also kill us if needed be, right? So that's essentially all that works, just to, there we go. Disconnected a little bit, and that's essentially all that happens. So this is the kind of setup that you're probably very familiar with. This is very simple, and this is essentially a direct dependency, right? Like, now the player clicker is directly dependent on the enemy health to exist, right? So let's say that in the future we also want a boss. Well, we'll have to do this again, for boss health, and we'll have to do this for the crate, for example. So if there's a crate, this will be a crate, and then we'll have to do a crate.break or whatever. You get the idea, right? As things really scale up, I'm gonna call this boss health, and then we'd have to do something like this, where boss health in here, and we deal damage to the boss. And this would be how your system would likely look as you added more and more stuff. But again, this is not scalable. Essentially, each of these that I'm making right here is exactly what I showed in here. It's one of these interactions. And we're essentially making a new one for every case. So make a good exercise out of this yourself. Every time that you notice you're doing something like this, essentially like if, you know, if you're doing a lot of checks and cases and special handling and stuff, you're probably not making a very clean and scalable system, and you'll likely end up having trouble with it later. Just mark my words on that. And we've all been there, right? I'm not trying to shame you or make you feel bad for it. I have been there too. We've all been at a point where we need to learn and make scalable stuff, and I take a lot of pride in the fact that I am still learning. I am by far not the perfect developer. Neither are you, or neither is anyone else, right? We're all just in this, and we have to learn and make the best of it. Right, so now we know the problem. We essentially know what we have, we know the problem, and we've sort of set and established a good baseline of this. Now, this is where some techniques come in, right? Some stuff that we already have accessible with C# essentially, right? Let's start with the first layer, which is a layer that I really like, and that is abstraction. So let's start by making a new component, and we can really call this whatever we want. This can be some sort of base health component, for example. And what we can do is we can abstract this, right? So let's do something like this. The base health component is just an abstract. And let's now take what we have in here, our damage, for example, and let's abstract that. So let's make a public abstract void damage, for example, in damage. And that'll be the damage that we want to give. Now let's go to our enemy health here and make it inherit from base health. And now you'll see that there'll be a red line under my damage here. That's because we already have the damage. If we didn't have it here, that'd be a red line up here. And that's because anything that is now abstract, we need to inherit from. Abstract is essentially a way of saying our class in here needs to inherit from this. So what we do here is we just say override to essentially tell it that we're inheriting from our script here to the damage. And that's essentially it, right? So now already with just this one level we have here, we can go into our player clicker and we can instead search for base health. And we can also just, for naming wise, just call this health, right? And so we just try and get a health when I click on it, and we'll deal damage to that health. Already at this point, we have helped ourselves a lot, because let's say that I wanted to make a new boss, for example. I don't have to make a new interaction here. The boss just also needs to inherit from base health, and we'll still be dealing damage to him. Does that make sense, right? So let me, for example, go and make, just very quickly, a boss health. And he will just also inherit from base health, and he will now have to handle it on his own, right? So I implemented, he dealt damage, and we can do debug.log dealt damage to boss. And we can do the damage here, for example, do the damage that we've dealt here, something like that. So it's really that easy now. So now, for example, if I copy one of my enemies, I'm just going to call this boss, give it the boss health script, remove the enemy health script, and then I'm going to put him over here and make him a lot bigger, something like that, right? Now it's very visible that's boss, and as you can see here now when I click here, we've now dealt damage to boss, and here we still deal damage to these little guys. Alright, cool. So already at this point, we've removed a lot of these, unnecessary lines that we do have. And one of the strengths as well of the abstraction is the fact that you can also have virtuals. So when you just do abstract, it's essentially a hard rule. You can also do public virtual void on hit, for example, something like that. And this you don't have to override. Notice how the enemy health and the boss health isn't screaming at me right now, but I can still go and override the on hit like this, but I don't have to. And this also gives a nice layer of freedom. For example, let's say that on hit, actually, we could, if I go here where I'm doing the text pop-up, we could, for example, play the damage pop-up, right? And then go back to my player clicker, and then where I'm doing it here, we can also just do health.onHit, and then we can deal 10 damage. And actually, to make it even cleaner, we can then go back into the, I guess here, let's just on hit, and let's now make this damage here a protected abstract void instead, meaning that it's no longer accessible from the outside. So now we're only going in through on hit, and what we can have is the base health can now also call damage with damage here, right? And it can set the text first. This now means that, let's say, for example, you, actually, let's go just test this really quickly, just so you can see what this looks like now. So now when I go and I hit, you can see the text comes out of all of them, right? because now the on hit is running for everybody and damage is still being handled individually on a per basis. But now let's say that the boss, we didn't want the damage pop-up. We can actually go take the on hit and then not call the base. The base on hit here essentially means that we're still calling what's in here in the base health script. But let's remove this base and let's just deal the damage directly, because we don't want to show the damage pop-up for the boss. As you can see now, when I click on them, the boss doesn't have the damage pop-up anymore. Right. This was just a quick example of using abstraction, and I hope that you are already familiar with abstraction, because it's extremely helpful. And another thing we can do is, since this is still a base health component, we can also actually just handle the health stuff in there. So let's do something like this. So let's go into the base health here. And I still want this to be a per read only. Let's do something like this. Let's have the damage here itself actually be, let's also make this a virtual just for good measure, and let's expand that, put that in here, and then we can also make a protected virtual void die, which will be called when they die, so they can just choose to override it if they want to. So for example, a simple example here could be, if we override it, I'll make this protected as well. And let's also just in awake in the base health also set up the current health properly. And again, if you want the health to be available, you can do it, make it protected as well. So we can just make these protected so that they can be used from everywhere. And same with the is dead pool. And also we can have the death here, for example, just calling like destroy, like game object, right? So when they die, they will just strictly destroy. But in this case, for example, so I cannot override, I don't have to override this anymore. So now, okay, hold on. So a lot of things just happened now. Let me go through it very quickly. So now essentially the base health script just turned into mostly what the enemy health was before. So for example, here you can see we're in the beginning, we're setting the health correctly. Everything will work, they'll get their health. They can take damage, they check if they're dead, and they'll also call die if needed be. And also for that sake, let's also just add the is dead check down here. And also they can handle their on hit, right? So the on hit is the incoming one. And we could actually choose to not make this one overrideable if we didn't want, and only override these. Like there's a lot of things. I think you should play around with abstraction in general. It's very powerful. And just going out here very quickly, you'll now notice how the boss also has health, and so does the enemies. Now you can see they can have individual health. And notice how the enemies, the normal enemies, they take a body because they're doing this little animation, right? So what they're doing is normally when you just die, when you just die in the base health, you can see it'll just call destroy. It'll just strictly destroy. But in the enemy health, it's actually overriding that and not calling the base, meaning it won't just destroy, it'll actually play that animation. This could be good, for example, if you wanted the boss to have some kind of other animation that's very grand, or what now you want, right? So let's try, for example, and kill the boss. So if I click 10 times on him, right, because we're overriding the on hit here and we're overriding the damage as well, right? Like that. Hold on, I didn't want to override the damage. Now let's go back and do that. So I'll click on him here. You can see he loses health, and as he dies, he just vanishes. Whereas these guys, they still play their little pop-out animation, right? So now you can easily see how you can handle things very easily on a per level basis by still just abstracting this out. But let's take it a step further and say now we wanted those, crates and the barricades that we can destroy. But the thing is, we don't necessarily want them to have health. We want them to work differently. Now this is where interfaces can come in really handy, right? So let's make a new script here. And let's just make it something like damageable. Now we remove the mono behavior, and instead of making a class, we make it an interface. Okay, so first of all, what is an interface? Now, similar to with abstraction, you make these, I guess we only made them all virtual here, but essentially when you make the abstract voids, as I mentioned, they essentially count as a rule, like anything that inherits from it has to implement this member. The same thing goes for interfaces. So what we can do is we can say this damageable has to implement, for example, a public void that we call onHit that has to take in the damage that we take. And you might recognize this a little bit because I planned ahead. And as you can see on our base health, we have an onHit actually. And as I mentioned, we might not want to actually override the onHit or be able to override the onHit. If you want, you can move the text pop-up or whatever you want elsewhere, but I think it's kind of clean that the path that you get in is not overridable, but anything that happens sort of internally, they can override. And now what we can do is we can go here and we can implement the damageable. Now it won't scream at us because we already have the on hit with the int damage as an input. You can see if I remove that, it will be very upset with us. And if I have it implemented for me, it'll do it like this. So as you can see, we already have it. And this means we can now on the player clicker go even one level higher and make an eye damageable. And now we can change this to be damageable instead. Now we've just gone a layer deeper. Now we're not even on base health, we're all the way back at eye damageable. Now, what's the point of this? Because the functionality that we have out here is exactly the same, right? So let's do something like, you can still click on them, they will still die. All the functionality will still be the same, essentially. So what's different? What did we just change? Well, first of all, I guess the text pop-up, I don't want to be able to damage them before we check if they're dead. But also, more importantly, back to what's actually relevant, let's make some kind of destructible, right? Let's make a crate, for example, right? Let's make a crate, and this will now be a damageable as well. So now let's do this, and let's inherit from what it wants us to inherit from. And now, instead of this, we actually maybe want to count the amount of hits, right? So private int hits to take, or hits to break, or something like that, right? Bread, yeah, bread. Hits to break. Right, and then on hit, for example, we can do something. Again, you could inherit from this, so we could make it an abstract as well, but I'm just gonna go ahead and make a private void damage. And then let's just do something like private int current hits 0, and then whenever we hit, essentially, we can just count this up. Actually, we don't even need the damage. And then we can make a private void break. Something like that, which will, spawn some loot and it'll destroy the game object. Like so. And then here we just do if underscore current hits greater than or equals 2 hits to break. Then we just call the break method, right? So something like this. So now I can easily just make a crate. And actually we can also very easily, I can just do the, what did I call it? Text pop-up, I think. I'll create text pop-up. And I can easily just do this at the transformed position. This was just my code, so don't mind that. And now I'm just going to do 1, or like 1 as a number. Or I'm going to do hit, for example. And I'm just going to make that yellow, right? Just to show that this is something else, even though it's all coming through the eye damageable. Now going out here, let me instead take an enemy and make it a crate. Let me put that over here. And let's make that yellow. Whoops. Let's make that, I don't know, let's make a crate like a grayish green color. Doesn't really matter much to me. There we go. So now here we have a crate. I'm going to remove the enemy health, and I'm going to instead, we're going to add the crate script. I'm just going to add a couple of crates. Right, so like that. So now when we hit play, I hit it and it'll just say hit. As you can see, and it'll say hit 3 times and then they break. So as you can see now, everything is actually going through this interface now to actually deal damage, and it's really as easy as that. And of course, you're gonna have way more stuff in the interface. What really matters is the fact that anything in the interface will now be accessible like this. Now, let's say that we want to be able to do other things as well. Let's say we want to be able to heal, or we want to be able to add status effects, or something like that. So for example, I can make an eye healable, which are things that can, gain health. And this will once again just be an interface we'll make. And let's, for example, just make a public void on heal, for example. And let's just say that should get an amount as well, something like that. Right, so now we can go into the player clicker. And what I can essentially do is I can also just make, I guess, a separate, I'm just going to copy this and make it mouse 1, so it's right click. And then here instead, it should look for eye healable. Of course, again, multiple raycasts, whatever, it's not the cleanest thing. Don't mind that. Right, so now when I right click, I will heal. And now let's go into the base health script, for example, and say that we also want this to be an eye healable, which means we also want, enemies to be able to get healed. And what we can do is on heal, for example, we can make also a, let's make a protected void, or virtual void heal and amount. And this will essentially be what actually handles the heal. So that'll be the amount. We'll just, first of all, I guess, check that it isn't dead again. And if it isn't dead, then we wanted to do it with green text here, for example. Want to pop up green text, then it should pop up the amount with green text. And it should add the health to the current health. So let's do something like that. And then plus equal to amount. And then it should also, of course, just check that, that it's not above max health. Otherwise, just set it to the max health, just so it can't get overhealed. You get the idea, right? Something like this, right? So now you could also handle healing on a very specific basis on enemies. And notice how crates, they don't inherit from healable, which means they won't be able to heal. So now let's go and hit play. And now when I damage them, we'll deal 10. And when I right click, you can see we'll heal them 10. And as you can see here, and actually, I guess another thing we can very quickly just check is just if the current health is already greater or equal to the max health, then we just return as well. Because I don't want to be able to, you know, see text either when we are not healing them. Now, let me check this first enemy, for example, which I think is the top left, yeah. As you can see now, we damage him down to 20, and when I right click, we'll heal him back up to 50. And notice how this has been as easy as just adding these interfaces, right? So now we have the damageable, we have the healable. So let's say that I wanted something else to also be healable. Let's say that we wanted to be able to heal the crates. Well, it's as easy as just doing healable, implementing healing, and just saying what healing does. For example, this might add a hit to break again. And then do, you know, if hits to break is greater or equals to, well, the initial, current hits, I guess, should go down, actually, is what we'd want to do. And if current hits is less than 0, we just set it back to 0, right? Like something like that, for example, and then we can just make this into a serialized field with the per read only as well. Just so we can see it in editor. And just to show you, like, it's that easy to implement healing onto something, right? So I go on here now, and you can see when I click and then I right click, and as you can see now, we're taking away current hits again. So I can click twice, right click twice, click twice, right click twice, and it'll just keep on giving. Right, so clean like that. So now it's really easy for you to also implement healing. You can do the same thing for status effects or whatever. And notice how all we really did was, in this case, we did add one more, obviously, integration, because healing is a whole different interaction from damageable. And this is essentially the boxes. We essentially just created sort of a new box around them. So if we go back to this, you should see this red box as the damageable. And then we also could plop a green box around the ones that are green, or essentially, I guess, a green box should be, you know, in a separate location with a pointer to that. But you get the idea. Essentially, this is very clean. Now we can very easily implement healing onto anything as well. Now let's take it a step deeper. You might already think that this is very scalable, and you'd be correct. This is already very scalable, but let's take it a step deeper, and this is where a lot really start falling through for a lot of people. And this is, of course, more niche to do, or to utilize properly at least. But that's generics, and generics are awfully powerful if you use them correctly. Now, in my case, I'm obviously probably not going to be doing them the due diligence that they deserve, because, well, you know, it's a big topic. Generics is a whole topic in of itself. Right. Well, so let's say that we have cases, for example, where we want to know what hit us because we want to act different. Let's say a simple case would be animations, right? You've been hit by a trap, you want to play a different animation. You've been hit by a gunshot, you want to play a different animation. You've been hit by something else, you want to play a different animation. And for this, we can use generics to identify what type hit us, right? So I can just immediately do what type, and we can actually also send through what hit us. So I guess attacker is a good word. Right. So here, for example, when we call on hit, we can call it with this, right? Which will be the attacker. In this case, this will be of type player clicker. We can make this very clear by also entering the type here, but you don't actually have to. You can see it grays out, which is because it automatically identifies that this means player clicker. But, it's still fairly clean. So let's go to the base health here, and let's make sure that we now implement this, right? So we want to implement a new, we'll just let it implement. And we can, just essentially, we can essentially just take this whole line, and I can just apply it to what we already have. So the on hit that we have here. And now we essentially have the context as to who or what hit us as well, right? And you could use this for various different cases. Let's do the same thing in here as well, on hit. And you could use this for various different cases, right? Let's say that you wanted them to unlock an achievement because a trap took out a crate, or you wanted to play some kind of animation based on who hit them, right? So in this case, for example, in the base health, we can just do a debug.log hit by, and then we can do attacker, for example, just to see what that logs out. And now you can see hit by player clicker, right? Which is, our player here with our player clicker component here. So now it correctly identifies also who damages us. And generics are a lot more powerful than a lot of people think, because generics can also mean, data that you don't yet know what to do. I showcase it actually in multiple of my videos. One of them being the inventory tutorial, which people have seemed to really like, and also the roguelike tutorials as well. Generics are extremely useful for scalable systems, and especially ones that needs custom data. Let's say, for example, different weapons that has upgrades, right? You'd want those upgrades to be dynamic data on a per upgrade basis, and that's very useful to have that data be generic. So you can go watch those tutorials if you want to see some actual use cases of utilizing generics. Okay, cool. This has already taken, what, I think about half an hour or so. But now I think we have a really good foundation for hopefully you understanding some of the tools that you can work with, abstraction, you can work with interfaces, and you can work with generics. These are 3 extremely powerful tools to make your systems maintainable and scalable, and it plays really well into, the existing component-based system that Unity has, but also in general the language of C#, which is object-oriented. Now, the next thing that we need to move into is actually networking in it. Right now, everything is completely single player, right? So I guess first things first, let's make this into a network identity. Let's make the onSpawned method, and let's just say enable equals to its owner, right? Now we already have set it up so we can spawn, individual player clicking functionality. Right, so let's handle this, and let's just quickly make a prefab out of the player, and let's add the player spawner here and feed that to player, right? So now we should already see the player spawn when we start, and there he is, and now I can click on things because I am the owner. All right, cool, that's a great start. And actually, let me open up the networking window here. I'm just gonna use Unity's. Right, so as we have it here, I'm gonna start playing, and as you can see, I click around here, I'll damage them, I'll even destroy them, but as you can see, nothing happens, right? We're not seeing anything. Nothing is networked, and that makes sense because our system, well, it isn't networked. So let's get into how we best in a modular fashion network this. Now, there's more layers to networking this than you might think at first glance, because it's easy to just go into the boss health, go into the enemy health, and start networking things directly in here. But actually, the more you can network something at a root layer, the better, because it'll typically mean it'll expand outward, right? So like similar to these systems, for example, we have the base health system. Well, obviously we're handling health and damage at this level, because then we don't have to do it at the boss health or enemy health level. The same rules really apply for networking. If we can apply networking at a base layer, which we have here with the base health, unfortunately you can't do networking within interfaces, but obviously we can network the stuff that the interfaces implement, if we so wanted to, right? So let's start thinking, for example, about damaging stuff, right? Who should be able to damage stuff? The thing with networking, and a good sort of rule of thumb in networking, is somebody has to, be the owner or the ruler of this object. Not everyone can control everything. I think it's generally cleaner just having one connection, one client, one something controlling it, right? Now we could be switching ownership. It really depends on what you're going for. Are you going for maximum servers, security, safety, anti-cheating, whatever? Are you going for maximum, sort of responsiveness? So for example, the current health. Let's start by making that into a sync var of the type int, and let's make this new sync var of 0, and then let's make it owner auth of true. And actually, another thing that you can do is you can actually initialize sync vars in awake. You don't have to do it here, which I quite like to do actually. So we can just take this, we can set that equals to new. And this can have the default value of the max health, and it can be owner auth to true. There we go. This is because max health is obviously a serialized value, so we'd want that to be able to serialize into the sync var. So already with this should help. And here we of course do .value, and here we do .value again, and down here of course we do .value and .value. I think that is mostly it. We just remove the per read only just for clarity, just so we can see the current health properly. Just gonna expand it, look at the value. So as you can see now, it initialized into 50. And as I hit play, you can see it goes 40, 30, 20, 10, and 0, and it dies. So everything still works the same, except if I go on to this here. Now, of course, given we remember to make it a network identity, and I go and I hit play, you'll notice that when I damage something over here, it'll act strange, because, well, we don't have the permission to change the sync var, because it's owner auth and we are not the owner, right? But we can damage it over here, not because we're necessarily the owner, because we are the server and there's no owner, meaning we are the controller of the object. Now, in order to actually then set the damage properly, we'd need to figure out exactly what it is that we'd want to do, how we'd want it to happen. Now, as you can see, we already made the sync var owner auth, which means some kind of owner could take control or some kind of controller. But we could also make it fully server auth, which would be easier but less responsive, right? So let's say that I remove the server auth or owner auth here, which would mean it would be the same as just setting this to false. That's essentially its default setting. So it's the same as removing it. And what we could do is we could have this damage, or for that sake, the on hit, always be a server RPC, right? So we can call a server RPC. Since we're on the unsafe rules, we can just call it directly. And this should now mean that the server should be the one always dealing the damage. So looking on here, for example, when we look at, let's say, enemy 0, and I'm going to click on enemy 0 here to expand the value. And I'm going to click on enemy 0. As you can see, it takes damage because the server is the one controlling it and taking the damage. Then you see it now it despawned as well. It got destroyed because, well, destroying and instantiating is also networked with PurrNet. So what we could also just now do is have the animation itself also be networked and be told to run on everybody, right? And that would be on an individual case. So on the enemy health itself, the die runs this little death animation, which we could just make into an observer's RPC, something like this. So now how it'll work is any player will click on a damageable, it'll run the on hit, it'll go into the base health, run the on hit, and this will already be ran on the server. The server will then run all this logic. The server will also be what creates this text pop-up, which, you know, might not be what we want. So we can also get to networking that, and there's multiple layers to do that as well. But more importantly, the server then calls die, and die is then overridden in enemy health, and because it's overridden here, it's ran as an observer's RPC. So let's go and check that and make sure that that works. So looking here, you can now see if I go here and I'll kill off this top guy. Ooh, and there we go. Both of them ran the animation just fine. And there we go. So now let's try and fix the text. But again, let's make it scalable. So one of the places here where we can really help ourselves is the fact that we know, and this is an assumption, but an assumption that I think is sometimes safe to make. This really goes back into actually what I mentioned way back here with we don't have to do more than necessary. I think it's pretty safe to say that we want these damage pop-ups to happen for everybody in general. So that means we'll have one caller and they will call it to everyone. And well, it should be as easy as just adding an observer's RPC here. Of course, making sure my text pop-up is a network identity. And I think mostly that should be it. They should now spawn the text for everyone given the relevant data. So let me go here, let me hit play. And now when I hit something, you can see that the text pops up also on the clone. And there you go. As you can see now, everything here seems nice and smooth and networked. Now, what I just did here actually matters a lot. What I just did here is I networked it once again on as base a level as I could. So as I mentioned with the health stuff earlier, with boss health and enemy health, I am trying to network as much as I can on a base level, right? So the base health here. And again, in this case, it was just an animation that's handled with the override. So that's a unique case and we want that to be uniquely networked. And well, the text pop-up is something we know will be a recurring theme. Anybody could potentially call it and they will just tell everybody to run it with the observer's RPC. Because with PurrNet, clients can also run observer's RPCs because of the unsafe rules. If you are not on unsafe rules, of course, you'd have to route it through the server. But of course, I expect you probably know how to do that at this point. Now, going a layer deeper, one thing here that is very relevant that we did is the on-hit is server RPC, but notice how this is actually a generic. This is part of PurrNet, which means generics actually also will work because our player clicker is also network identity, meaning it can be networked. So let's once again just try and log out our attacker here. Because now you'll notice, regardless of where I click it, the server will log it because it is within a server RPC. The server will log what clicked. So as you can see here, it'll say player clone, player clicker, right? And this is the clone. And actually we can take it a little bit of a step further, I think, and we can add the attacker as context. We cannot. We can do if attacker is, and let's just do of type mono behavior. This is essentially just a little sort of safe way to cast it. If it is, then we can set it as a reference here, just so we can easily in editor identify which client is it, right? Because they're both named player clone essentially. So as I click here, you can see this will be the first play, the second player clicker. When I click here, you can see that is the owner ID of 2. When I click, I got the first one. So as you can see, we're now correctly getting both of them as references, send over the network very cleanly, and just with a single server, obviously. This is really where some of the power of PurrNet comes into play, is when you really want to work with true modularity, you need generics. I know a lot of people will argue you don't. I strongly disagree. I think if you want to make something truly modular, you need generics. But of course, it depends on the system. Okay, moving a step further now. Let's also say that we want to return some kind of data as for what is our hit, right? So let's say, for example, we want some kind of hit result. Let's say that the damage is blocked or something, and we want to be able to react to that. Well, let's go back to our iDamageable here, and let's actually add some public enum. Let's call this damage result. And this can be something like damage dealt. It can be damage, I guess we can just call it blocked and dealt, for example. And it could be other things as well, but let's just say that we now want to return the type of damage result. Now in PurrNet, you can do this with tasks, or you can use unitask. But I'm just going to be using normal tasks for this case, just because they are, built into C#, so just to keep it clean. And we want to return the type of task with damage result. This means that it's now actually a returnable. So in this case, we can, for example, do, well, here, of course, we have to do the task with the damage results, and we have to do the same thing in the base damage in here. And to make life even easier for yourself, you can just make them async, because that makes it a lot easier to just return. Otherwise, just to give you the context here, you'll have to return task dot from result, and then you'll have to return the damage result that you want to return dot dealt, for example, in this case. You can do this, and this is completely viable. Of course, we'd have to do return, and this is completely viable. I typically like just making them async. It really doesn't cost anything, and it just makes it so much easier. Well, I could be wrong. It's an assumption I'm making, but I haven't experienced it should cost anything. It'll just tell you it's not being used as an async, but that's really all. Right, so here, for example, I'm just returning damage as damage dealt, and we can do the same thing in here. I just make this async, and I'll just return it as, regardless damage has been dealt. And actually, we could also do like a off type damage, that it was finished or that it was missed or whatever. You can add as much as you want, killed or whatever. Right, but let's say that I just want delta blocked. Now let's actually use this for something. So let's make it random. Let's, for example, do if random.range on the server, that'll do something between 0 and 100. If that is less than 49 or whatever, or 50, I guess, for 50% pretty much. It'll have to be 101 because it doesn't take the highest. Then it'll return the damage dealt of blocked, otherwise it'll actually deal the damage. And this now means we can go back into our player clicker, where the onHit is now actually returning something. And we can now await this, right? So let's make this update an async. And let's have this await the result. So let's do var result equals 2, and we're gonna await our hit. And then we can do debug.log hit result is result, right? And we can actually, make it a little bit cleaner here just for our sake. So let's do damage result equals 2. And this is where you can make an assumption that it's just blocked. Look here, down at the bottom, I just want to log it out, and then we can just literally do the same thing for this damageable. So we'll just await. Oh, sorry, not on heal, just on damage, right? But actually, I guess this was completely fine, and I'm silly. Yeah, so now that we have it like this, we should locally, the one who deals the damage should log out what actually happened as well, whether the attack was blocked or what happened to it, right? So in here, you can see now that I click, it'll say that we actually dealt the damage. You can see the damage pop-up showed. Now it was blocked, damage pop-up didn't show. And actually, we can make that a little bit better. We can actually, when it is blocked in the base health here, we can just do when it actually is blocked. Then we'll want to do the text pop-up, dot create text pop-up at transform.position. The text will be blocked or block, and the text will be blue, for example. Can do whatever with that we want. So now we can, for example, easily see. So now you can see this was blocked, this dealt damage, this was blocked, this blocked, dealt damage. And as you can see, now everything here is nice and synced. I'm getting blocked a lot. Yeah, so you can see now we can correctly log it out. The client successfully gets the value. Now, you could easily also just make the argument, what am I, right now, obviously, we're not using the result for anything, but you could use this, for example, let's say you wanted to use it for sound effects, wanted a different sound effect depending on hit or block, or you want to do something else. Let's say that you are damaging the weaponry, and a block damages your weapon more than a non-block, for example. Well, you could handle that based on the result, or the server could be doing it or whatever. But this essentially mostly is gonna end here. I'm just gonna do very little more talking. Essentially, I hope that you get the idea of why this system is scalable, because we're doing a lot of things, right? We're using interfaces to essentially stack and be able to add more and more functionality onto things, right? We could have something completely different, or it could be that, let's say you only wanted the enemy health to be healable. Well, you'd add the healable here and not add it to the boss, and of course remove it from here. Or various things, you wanted things to have phases, stages, stack, effects, or whatever. You could do that through a bunch of various interfacing, and essentially just only making the interactions for the interfaces and not for the individual components. Other than that, also obviously being able to return values is just always really, really useful. Again, let's say the server just had to calculate something, you could just return the result of the calculation or something like that. So being able to return values and also being able to work with generics is just extremely powerful. And I think a setup like what I've just done here, perfectly fine, just shows the power that you really have with PurrNet. The fact that you can return values, you can utilize generics, and for that sake, to make it even better, you could actually also make this static. That would work perfectly fine. Obviously, this whole thing wouldn't work in static context. It's very much based around, the mono that we're on. But, you could work perfectly fine in static as well with PurrNet and network logic. So in theory, actually, what I did all the way back here with the text pop-up, you could actually just make this the observers obviously as well. This would work just fine as well. And you're essentially networking it at a layer just before. It was just out of habit, I put it here. But you could essentially do, and actually, to be honest, it's checking. No, actually, it's networking on the instance here. I think that's fine. It's already passed the check. Either way, you get the idea. You have a lot of power, a lot of freedom with the fact that you can work with statics and generics and return values. And especially if you work well with abstraction and use that to your strength as well as interfacing, it can really give you a lot of freedom, a lot of scalability, and it can make your systems a lot easier to maintain. Because now think about it, for example, with what I just did, I wanted to change at a core level how we acted with damage, and all I had to do was just go back and change essentially how we acted on it here. And of course I had to go through the various integrations to make sure that they were still relevant. But of course you can't avoid everything, and you can't safeguard for absolutely everything. You can just make your job as easy as possible in the future by essentially making setups like this. So I hope something like this can inspire you to make your own systems. It doesn't have to be damaging systems. It can be coin systems, it can be weapon systems, it can be inventory systems. There's so many systems in games. Like, again, currently, for example, as a hobby, I'm working on a little slot machine game and a little puzzle game and stuff like that. And I'm using a lot of abstraction and a lot of interfacing to my power to be able to make these puzzles very easily plug and playable and make more puzzles and expand on them and everything like that. And I'm having a lot of fun and really enjoying it, and things are just working really well and very cleanly because they're being networked at a very core level whilst working with abstraction and interfacing as well to my advantage. So yeah, overall, I really just hope you learned something new with this video. I always hope that they're helpful and that made sense. And other than that, I just wish you a wonderful day, and let me know what you think in the comments and what other videos you might like to see.